Right. So now that we have done the causal inference, causal attention masking, we said we are going to add something that is very important. And this is not important to just large language models. It is important to deep neural networks. If you have done deep neural networks before or you have trained an image classifier using convolutional neural networks, you know about dropout. Dropout is essentially a way to disable or to ignore certain units in hidden layers so that your model does not depend on on a single set of units. Dropout is a random way of disabling certain units. So if we have a neural network, let's just say we have a neural network like this, and this is just very random. For example, let's say this is our neural network, these are our hidden layers, and then we have an output layer maybe with two, and they are very connected. I'm not going to draw the connections, but of course they'll be connected from layer to layer, connected from layer to layer. When you use dropout, you then ignore, if you say whatever ratio you're going to use, it can ignore this unit, ignore that unit, and keep it like that, so that when it's training, it should not otherwise sometimes what will happen with neural networks, because they are so greedy, they might end up just depending on one unit or a set of units for their training, and that leads to overfitting. So dropout is a way that is used to avoid overfitting, because we will drop, as the name says, we will drop or ignore certain units at random. We ignore certain units at random when when we are training this model, and but then at inference we activate all of them. We activate back all of them. So now, how do we do that in LLMs? Is the same principle, because it's a deep neural network, right? And this happens in transformer architectures, even in our GPT models that we use. Um, it is typically applied after. So there are two stages or parts where you can apply. After calculating, you can apply dropout when after calculating attention weights, um, or after applying those attention weights to values, or after applying attention weights to the value matrix. Remember, you apply your attention weights to the value matrix when you want to calculate those context vectors. So you can apply to after calculating the attention weights, you apply to those attention weights, you drop out some of them, or after you have applied attention weights to the value matrix, as to the value matrix of value vectors. That's what we're going to do. Is we're going to do it this way. This is the most common one, where you apply after calculating the attention weights. So let's quickly. I think it is best to just let me see if I can get an image that explains this. Perfect. So this will work. So you remember we had our masked attention weights like this. Let me just change from the pointer to this. You remember we had our masked attention weights here. This is our masked attention weights. So what we are going to do from these masked attention weights is we are going to, or not from there, we are going to create on the side a dropout, just like we did a dropout mask. You remember we created, for us to create these masked attention weights, we created a mask. We used minus infinity, and then we soft masked it, and then we created these uh, masked attention weights. We're going to create another mask, which is the dropout mask, but with the ratio, with the dropout ratio, with the dropout ratio. It then just randomly chooses cells that it's going to drop out. So it randomly chooses cells that is going to drop out. And when we put these two together, it's not going to be addition, but when we put the two together, some some cells are going to be dropped out in our attention matrix. So as you can see, this one is safe. The one next to it, yeah, it was a gray. It was a gray. So, but it's still safe. Then in journey, they are not safe. These 0.55 and 0.444, they are not safe from dropout. So they get dropped out. And then the other ones as well, some of them are safe, some of them are not. So if they are in the same position with the dropout mask, they get dropped. That's essentially what we're going to do. So what we end up with is drop, this attention matrix with dropout. So this becomes a masked attention weight matrix with dropout. That's it. So let's see this happen in code. So we are going to quickly switch to our Google Colab. Nice. So now we drop out. Let us just move the images so that we can just focus on the codes to make it easier. So we're going to apply 50% dropout. What we're going to do is to create that dropout matrix, and it's a 6 by 6 because, of course, what we are dealing with is a 6 by 6. You don't have to cram a 6 by 6 by this manually type hard coded like this. You can just look at the shape. Look at the shape of our attention matrix. That's the one that you are going to use here. So it'll be a 6 by 6 applied with the same shape as the attention matrix. So it's going to be like, so this is an example of the dropout matrix that has been created. Now, someone will say, "Oh, why does it have twos and all of that?" Is because we are using this dropout of 0.5% or 0.5 or 50%. So we are dropping half of the values that are there in the matrix. But the problem with that is we now have to scale. It will automatically do that. PyTorch automatically does that because we want to maintain the impact or the effect of what the attention weights were. So we then invest it, and then we create a scaling factor. It creates a scaling factor. So when it creates a scaling factor, it multiplies. It comes out as ones and zeros, and then multiplies the ones that are not being dropped out by the scaling factor, or it just multiplies the whole matrix by the scaling factor. Because here we're dropping out 50%, the scaling factor is just going to be 1 divided by 1 minus the dropout rate. So 1 divided by 1 minus the dropout rate is just 1 divided by 0.5, which is 2. And so it multiplies that ones and zeros, where the zeros are where we are going to drop out, the ones are going to be the safe ones, and multiplies by the scaling factor. That's why the twos are there. Now that we have this dropout, that we have calculated. This is the dropout matrix. And we now just apply it to our attention matrix. And when we apply it to our attention matrix here we're creating it's a special, like special function. It's a dropout function in PyTorch. So that you input like what do you want? This torch ones creates ones and zeros. It creates a matrix of ones and it creates a matrix of ones actually. Creates a matrix of ones with it's a 6 by 6 matrix of ones. And that's the one that we put into our dropout function, and then we get back this with the scaling factor applied. And the zeros are in positions where this function randomly chose where we are dropping out. And when we apply this dropout to our attention weights, it's going to select some parts to be equal to 0, and it's going to multiply the ones that have survived by the scaling factor, the 2. So that's why the first part here for attention weights is just 2. So this part, the example, you don't have to do this part. You just need to create the dropout and then apply that dropout to your attention weights. This was just to show as an example of what it comes out as if we're using ones. But we have already have our attention weights. These are our attention weights. So drop out random cells here and increase the other ones by the factor. That's it. So now we have this. So this is now our this is now our dropout. This is now our masked attention weight matrix with dropout. With dropout. Some of them have survived, some of them have gone to zero. Masked, the top right was always going to be zero because it's masked. So that's it. It is a very, very important is a very, very important step in large language models or deep learning because we want to avoid something called overfitting. We do not want our neural network to depend on a set of layers and a set of hidden units. We want it to randomly drop, and that improves training. So that's what we wanted to emphasize. Now, in the next video, we are going to put all these principles together and create our causal self-attention class. So let's see how we are going to do that in the next video.